So today I'm going to talk about F1, which is relations and functions. So our goal today is to talk about what sort of mathematical relation makes a function. So in math, what we do is we take relationships like the size of a pizza and its cost. Okay? There's a relationship. You know that as the size of a pizza increases, the cost will increase, right? So there's a relationship there between these numbers. So if you get a 12-inch, maybe it costs $10.99. A 14-inch might cost, you know, $12.99, something like that. All right. There's a relationship between these numbers. These numbers are called ordered pairs. So a relation is a set of ordered pairs. So you're going to need a couple of handouts for this lesson. And the first handout I gave in class was blue. Input output table and mapping diagram, and remember we folded this in like so. So we have sets of ordered pairs, input output table. All right, so let's talk about how to represent a relationship. So mathematically, how do we represent a relationship? And the best way to do it is with a set of ordered pairs. So let's put in some ordered pairs. So let's say that we have the ordered pairs of 3, -2. No, take that back. Let's make it 1, -2. 1, -2, 3, 4. 2, -1. 3, -2. -2, -1. And 3, 5. All right. So remember, this curly bracket is the thing that tells you that we have a set, and each set of ordered pairs, remember an ordered pair is an x value and a y value. All right. So this demonstrates a relationship, just as the size of a pizza and its cost demonstrates a relationship. Maybe this relationship, I can call it P, is the relationship. And the ordered pair is 12, 10.99, 14, 12.99, etc. All right, and maybe I have more pairs than that. I'm sure there are more sizes of pizza than a 12 and 14-inch pizza, but so this is the relationship without context. All right, that's what math is all about. It's about relationships, a lot of times without context. So how else can we relate? How else can we show this relationship? Another way to show this relationship is on a coordinate plane. Remember, a coordinate plane is the x and y axes. Right? Let's readjust here. So the coordinate plane is the x and y axes, right? So we can plot our ordered pairs. So our first ordered pair was 1, -2. So when x is 1, y is -2. Okay, so 1, -2. Then we had 3, 4, 2, 3, 4. That's right here. This is 4. Then we have x is 2, y is -1. Then we have 3 and -2, -2 and -1. And then we have 3, and 5, right? So that's what the graph would look like of this ordered pairs. Now, I want you to note that any graph, let's say I have a graph that's this squiggly line here, okay? This is the x-axis, this is the y-axis. And this graph here is a set of ordered pairs. It's just so dense that there's no space in between those ordered pairs, all right? So we can't see all of the ordered pairs, but they're there. There's so many of them, right? And that's what a graph is. It's a set of ordered pairs. It's a set so long I could never ever list it out in the set notation. So we use a graph, and sometimes we could use an equation to represent a relationship, and we'll get to that a little bit more later. All right, so other ways that we can represent a relationship, so we can represent it as a set of ordered pairs, we can represent it on the coordinate plane, and we can also make an input-output table. So for an input-output table, the input is always x, and the output is always y. And when we make a vertical table, we have the x on the left and the y on the right. And on a horizontal table, x on top, y on bottom. So for our example, put the x here and the y here. And then what are the x values that we had in our ordered pairs? Our x values were 1, 3, 2, another 3, -2, 3. And what y values did they go with? Well, this one was paired with -2. This 3 was paired with 4. 2, -1, 3, -2, -2, -1, 3, 5. All right, and we could write this horizontally as well. 2, 3, -2, 3, so 5, -1, -2, -1, 4, and -2. All right, so that's a way of using an input-output table. It's the input-output table, right? Inputs on the left, outputs on the right. All right, so another way that we can represent a relation is with a mapping diagram. So it has two shapes usually. The left is the x values and the y is the right. Now notice this says without repeats. Occasionally there are some graphs that do have repeats or some mapping diagrams. Some people do have repeats in it, but for our purposes, let's write out what we have without repeats. So I have an input of a 1, 3, 2, here's a 3 again, and a -2 and another 3. So there's a 1, a 3, a 2, and a -2. All right, that's without repeats. And for our outputs, our y values, I have, let's see, I have a -2, there's a 4, there's a -1, there's another -2 and another -1, and then there's a 5. Now, what we do is we connect these values with an arrow. So 1 is related to -2, right? They have some sort of connection. 3 is related to 4, but as you see from our tables above or from our ordered pairs, 3 not only maps to 4, it also maps to -2. Sorry, you can't see that. 3 to -4, 3 to -2, and 3 to 5. So I need to draw 3 different arrows from that 3, right? Now the 2 is mapped to -1, and the -2 to -1. So we should see 6 different arrows here because I have 6 different ordered pairs, right? 6 different relationships. So not 6 different relationships, 6 ordered pairs that makes one full relationship. So those are the 4 ways of representing a relationship. So now let's go to what it is to be a function. In order to answer this question, we're going to go to our next handout, Relations and Functions Review. So what is a function? A function is where a relation has only one output for every input. What this means is that x cannot be repeated. If x is repeated, that means it has multiple outputs, and it's not allowed multiple outputs. It can only have one, right? So let's look at these examples. Here, we see a 2, 3, 4, and a negative 2 as my x values. So no, there are no repeated x values. So is the relation a function? The answer is yes. Now, in this mapping diagram, what we see is we see a negative 2 goes to 9, the negative 2 goes to 2, also a negative 2 goes to 1, and a negative 1 to 1. So are the x values repeated? And the answer is yes. Negative 2 has 3 different solutions or different matches, right? Negative 2 to 9, negative 2 to 2, negative 2 to 1. So there are 3 ordered pairs that have an input of negative 2 but different outputs. So is the relation a function? No, it's not. So let's go to these next few examples. Tables. Looking at this table, I don't see any repeated x values. All right, and it doesn't concern me that each y value is the same. I'm looking for repeated x values, and I don't have any. So is the relation a function? Yes, it is. All right, now going over to graphically. We are going to use what's called the vertical line test. The vertical line test. What this says, this vertical line can only pass through the graph once, right? If it passes through the graph once, it means every x only has one y. Every input only has one output. We don't want multiple outputs for every input. Now looking at this graph, does it pass the vertical line test? Well, here we see that no, indeed it does not. If I draw a vertical line here, I have x is 2, and when x is 2, y is negative 2. But also I have when x is 2, y is positive 1, 2, 3, 4. So I also have 2, 4. So does the graph pass the vertical line test? The answer is no. The vertical line passes through the graph 2 times. No matter where I draw the vertical line, it'll pass through twice. It only needs to pass through twice in one place, twice, 2 or more, to fail the vertical line test. So is a relation a function? No, it is not. So a little bit more on the vertical line test. In the vertical line test, what I might see is I might see a weird function that looks like this. It's maybe a line and another line. And what I see here is that if this relationship, if that's what it looks like, this relationship is not a function. And why is it not a function? And the answer is it passes the vertical line test every place except, right here. The x here shares 2 different y values. All right, the x is repeated. Here and here, there are two different y values.